Good morning, everyone. Today is August, was it the 15th of 2020? And this is the John Chappell Natural Philosophy Science Chat. So this morning we have James Keene and we have Bob Gray. So how you guys doing out there? Can you hear me?
Yes, hello, hi, fine.
Oh, your picture went away, James. Oh, there you are.
Yeah, I'm eating a sandwich.
Eating a sandwich?
I'm eating.
Yeah, what time is it over where you're at?
Oh, it's 10 a.m.
10 a.m. Oh, not bad. So,
Yeah.
any interesting discoveries this week?
Well, so I have my mouth full. Sorry.
Yeah,
Well,
that's
we had an exchange in email where a few weeks ago, I guess it was you who mentioned that the so-called fundamental constants had been derived previously by other dissident scientists and so forth. And you emailed me an example, and it turned out that that was not a derivation, in my opinion, from a first principles, because they derive the speed of light from use the it was. And so, as far as I know, we remain our unique position as being the only ones to explain this unexplained data, which is wrongly called the fundamental constants of physics: speed of light, Planck's constant, electron mass, etc. So that's now that my mouth is not full, I guess that's my comment for the morning, and I'm feeling pretty good aside from that. But I come here to listen and to learn, and one thing I've learned is that none of the dissident sciences have any anything to falsify or whatever binary mechanics, and I'm very very happy to see that and to learn that.
well. I guess what the problem is that it's actually almost impossible to falsify any theory because as long as it has some logical meaning, then it's hard to falsify. Like if I have a theory where my socks are disappearing out of the dryer, I can easily hypothesize that there are little elves who are coming in while I'm doing the laundry and stealing it. A perfectly reasonable hypothesis, which basically no one can falsify. Right? It's like, yeah, that makes sense. While I'm doing my laundry, little elves are coming and stealing my socks. So the inability to falsify really isn't a very good gauge of the provability, but I guess the viability of your theory is what I would say. I would say that.
Well, maybe we could go to the inability to compete.
No, I say
no one has been able to duplicate derivations of this unexplained data, which is called the fundamental constants, from another set of first principles. And my set of first principles is like very minimalist. All it is exploring the ramifications and consequences of full quantization of space time and energy. You know, that's a very minimal. You know, because already the idea of quantization is generally accepted. For example, in electric charge, elementary charge is accepted to be quantized, and so forth. All I've done is.
Theory starts with quantum.
So it could be that
Right,
what
exactly.
the key point, Franklin, is lack of competition. I have no competition at the moment because no one else has used a different set of assumptions and come up with these results yet. And one reason I'm here is in case anyone does that, I'd like to know.
Although I would say that I have run into dissidents who basically claim exactly the same thing. There's another guy, he sent me this CD and he derived like all these constants, you know.
Well, I'd like to see it. The one that you sent me in the email failed. So if there are others which do not fail, I would like to know.
No, it's not a matter of fail. It's just that they do it, but there's different starting assumptions. I mean, your theory itself assumes that, you know, there is a fixed quanta of length and time and, you know, mass. But, you know, that's where you started
they
from.
Don't do it. They don't do it. What they do is they show, just let me make this point, please. They show interrelationships among the unexplained data, among alpha, speed of light, Planck's constant, electron rest mass, etc. So that none of these and all of these that show the interrelationships among this unexplained data show that there's actually a smaller number of underlying variables. This is the way a statistician would look at that. Now, but none of them, and you emailed me an example, have derived any of these constants from first principles without using other unexplained data.
Well, you in fact,
that
do that
is the key. If you're going to show interrelationships among the unexplained data, you're basically showing, in my opinion, nothing really fundamentally new.
But you do that yourself.
Well, no. The only starting point is the quantization of space-time and energy. I don't.
What you're doing. You're doing the same thing. And in fact, your constants are actually experimentally derived. So I'm sure you baked in the speed of light into those constants.
Show me where. It's simple logic and math. You can say anything you want, but your responsibility is to show what you're saying is true. And I'm saying it's false, what you're saying.
Well, the thing is, I'm saying that you're starting off, so you're complaining about the other theory starting off not on basic fundamental constants. But your theory does exactly the same thing. You've derived the quantization for these three things out of middle of air, and it's the same thing, James.
The same thing as what?
The same thing as what these.
I don't understand what you're really saying.
They start with, like, you know, the mass of the electron. It's like, okay, that's fine because that's a measurable thing.
Who is they?
Like the E-polar theory. I mean, that's what I sent you. I sent you the E-polar theory, right?
Well,
the speed of light is a mechanical thing through a crystal matrix, right? So they're deriving the speed of light as being equivalent to the speed of sound in some material. So in that way,
and
it's
the paper that you sent me uses electric charge, which is another unexplained data.
But it's perfectly fine.
If you want to play the game, you have to explain the unexplained data without reference to other unexplained data. It has to come.
No, you do not.
100%.
You absolutely do not.
Okay, that's fine. You may have that position. I have no problem with that. we're
I mean,
good.
if you're starting with
It would be from first principles only and not merely showing interrelationships among the unexplained data. So that's fine. I mean, we've drawn the line. That's good. Now it's clear what my position is and what yours is. Yours is that, as I understand it, that showing a relationship among the different fundamental constants is okay. You're actually doing something new. My opinion, and now it's clear, this is a good conversation, is that you if that's involved, you're not deriving any fundamental constant. You're simply showing an interrelationship. It must be from first principles of a physical theory. And by the way, the standard model, the most popular physical theory in physics right now, admits that they cannot do that, that their first principles fail to derive from those first principles in the standard model any, not even one of the fundamental constants. So they admit what I'm saying. In other words, I'm not saying anything in contradiction to what the overall physics community is saying. All I'm saying is that if you look at my work, it's the only work in physics today where any fundamental constant, and I've done about 6 or 7 of them by now, was derived only from first principles. Yeah, so this conversation is good. It clarifies what my position is, what yours is.
Yes, it clarifies that I think it's fine that if you have a physically measurable quantity, like electric charge, and if your theory is relying on using that electric charge to calculate something different, which is like the speed of light, right? Charge and speed of light, two completely different things. Then that's legitimate. And now your point being that, well,
I'm saying that I agree. That's legitimate. But in the zoo of physics, that's the cage where we're showing interrelationships among constants. That I can use one and I can use whatever theory I might have and get another one of them. Well, that's what they're doing. Look up any of the fundamental constants, and they're going to give you a bunch of equations in, say, Wikipedia or wherever you want, showing how that fundamental constant, speed of light, fine structure constant, electron charge, all of these basic ones, how they're related to others. And they'll give the formulas and the whole deal. So that I have no problem with that. Someone wants to continue along those lines, fine. What I'm saying is that what we need, the greatest body of unexplained data in physics, is the fundamental constant, the speed of light. You have to explain that. And you can't explain. The full explanation would come from the first principles of a physical theory. The standard model, the most popular physical theory, admits it cannot do that. My position is that binary mechanics, as a comprehensive physical theory, claims it can and has done that. It's as simple as that. All the papers that people with other theories showing interrelationships among the constants are just fine. I have no quarrel with that. It's just that that's a different cage in the zoo. My cage is the cage in which you can only use the first principles of a physical theory to derive unknown data, such as the speed of light. I consider that just unknown data, or unexplained data is a better description. Sorry to talk so long, but I think this clarifies the issues that we're basically not in disagreement. According to my criteria, I have X, Y, and Z. According to yours, you're happy with such and such, and that's fine. There's peace on earth as far as I'm concerned. I have no not being interested in explaining this data. Basically, the opinions different than mine, I would categorize as saying, basically, you're conceding that you can't explain the fundamental constants in terms of physical theory. But what you can do is show some interrelationships among them, like everyone else has, and that's an old story. It probably goes back 50 years. There's nothing new in it. And I said, well, that's fine. I have no problem with somebody spending their time doing that if that's how they want to spend their time.
So is
And ask Bob Gray how he's doing now. You know, like I'm feeling self-conscious with all this attention, you know.
well, yeah. So can I talk? Well,
Yes.
so is your big difference, your stick here is that you can derive things like the fundamental charge, right? Versus mainstream, which is happy to use that and then derive a whole bunch of other different physical characteristics. But your claim is that you can, say derive the fundamental mass of the electron and or its fundamental charge. Is that your claim?
Yeah. In other words, my claim has to do with what science is all about, which is making observations such as measuring an electric elementary charge, electron mass, speed of light, making an observation and developing a physical theory which can account for that observation.
But you're
really that simple. You're more complicated than that.
You still have the fundamental time, length, and was it mass or you have time, length. What's the other one?
Energy expressed in mass, so that it conveniently fits with the units of measurement in physics. You know, mass, length, and time.
Mass, length, time. Now, but you can't explain where those three things come from.
I haven't even attempted to do so.
Yeah, so I mean, even your theory.
So you're welcome. Come on in and explain those. Come on in and explain those. You're most welcome. There's an empty slot for you.
Yeah, I mean, even your theory eventually rounds out into something to the same complaint that you have, which is that you're showing the interrelationship of three fundamental constants to explain all the other constants, right? It's just one layer down, right? It's like, standard physics stuff right there.
That's a fair explanation. And then that's a fair description, frankly.
You explain the 27 equivalents in terms of three fundamental constants. Well, that's better.
It's like you have a set of equations, and you're saying, can these equations be reduced, with say 4 or 5 variables in the equations, but how many variables are there really underlying? This is the whole basis of factor analysis, which is basically extracting eigenvalues and eigenvectors from a matrix, which is used in particle physics as well as in statistics, even in personality research, and IQ tests, categories, which questions correlate with other questions and so forth. And that's the name of the game, to reduce a lot of complexity down to its simplest possible enumeration. And so that's, So, hey, you're absolutely right.
Scientific philosophy, that's good. Well, now getting back to my example of the socks disappearing out of the dryer and how that it's, virtually impossible to, disprove something that you effectively made up in your own mind. Now, in science, I would say that the thing that is lacking in that hypothesis and also lacking in your theory is some kind of physical experimental proof of your hypothesis. So in the case of the elf stealing,
that's why I did. Go ahead, Franklin.
Let me explain. So just as kind of a rule, let's try not to interrupt each other, and to stop every once in a while when we're talking. Okay, so let's just try and do that, so we're not talking on each other. So in the case of the sock stealing elves, the physical experimental proof would be to set up a camera while I'm doing my laundry and seeing whether the elves actually come, open the dryer, steal the sock, and disappear with it. So that's an experiment, physical experiment, done in the physical world, which proves my hypothesis that it's little elves who are stealing my socks and not cats just stealing my socks out of my sock hamper or something like that, right? So there can be any number of hypotheses. I mean, this is what we do science, that we do physical experiments which can confirm the hypothesis in the way that we suggest it's happening, right? So my criticism would be to you, Jane, which is that you kind of have that same problem, that, what is a physical experiment done in the real world, not in computers. I mean, computers are fine. Computers can emulate things, but ultimately it has to be something in the real world to confirm what your hypothesis is. So,
okay, Franklin, if people were to exalt me to the point of playing 4D chess, they might put the conspiracy theory out that I've maneuvered you exactly into a trap. And the trap is that I have made such predictions about, for example, the effect of surface temperature on gravitation. I've used other people's data collected with lunar laser ranging and from the Grace Twin Satellite Project, showing that my hypothesis is correct. Ironically, I had sort of the skeptical position that you have, and rightly so. I mean, everyone should be skeptical of things, of my own work. And the original lunar laser ranging study, which was where the binary mechanics hypothesis was confirmed. And by the way, this trashed general relativity and universal relativity, universal gravity of Newton, as well as being the full explanation involved. Yep, I've done it. Okay. In other words, I've gone to the washing machine and seen the sock being taken out mysteriously. To use your example, I've done that. And so somebody might say that I'm smarter than I really am, which would be false, that I actually maneuvered you into this. But you've actually brought the horse right to the water to drink. And in fact, I've done those studies. And in fact, I did the studies to disprove my own theory, and had to go over the data over and over again very carefully, because I was a bit disappointed. I said, well, this would be the end of it, because I've made a prediction that there's no way I can escape if this prediction is not confirmed. But unfortunately, the prediction was confirmed and general relativity was debunked, because general relativity cannot explain the data that other people have gathered with regard to lunar laser ranging, as well as the Grace satellite data. And I'm waiting for someone to do the GRAIL data, which is the twin satellites supposedly measuring gravity orbiting the moon. I've downloaded a lot of that data, but I'm waiting for someone to analyze that data and either throw out binary mechanics or throw out general relativity. If the studies I've already done in the real world with real data, not a computer simulation, can be debunked, and they've been out there for a long time and no one has debunked them. Yeah, so if there's a methodological flaw or whatever it is that you want to put forth, I'd like to hear it. That's one reason I'm here, is to learn what other people have think about these things.
Let's see. So why don't
and what they show. There's a comment Alistair made.
Why don't you remind us what the lunar ranging experiment showed and why your theory predicted that?
Okay, what I measured lunars. Well, the theoretical prediction was that objects tend to move in the direction of greater quanta density in binary mechanics. Okay, so how do you increase quanta density in the vicinity of an object? One thing you can do is radiate heat energy, which are quanta going out to from the object to the surrounding volume. Now, so I used moon phase as a proxy for the surface temperature of the moon, which if it increased, there'd be more quanta being radiated, right? Okay. And then I used the lunar laser ranging as a proxy for the amount of gravitational force involved. The result is quite simple. With increased surface temperature in the direction of Earth now, okay, because that's what the phases of the moon are all about. With increased surface temperature in the direction of Earth, in other words, closer to full moon from our perspective on Earth, the moon is closer by some 10,000 kilometers to Earth. Okay. And that's not, those are measurements which people spent billions of dollars to set up all the equipment and infrastructure required to make those measurements. And yet no one has had the guts to attempt to even replicate that study that I've done, because it throws out general relativity, has no, you see, when most of the illuminated portion of the moon is facing Earth in what we call full moon, the general temperature of the moon is unchanged from when we have almost, what do you call it? Not full moon. Like the illuminated area is facing away from Earth. So what my data showed is that the moon tends to travel in the direction where the surface temperature is the hottest. It's illuminating, it's radiating, excuse me, more quanta in that direction, and then it moves in that direction. And that is what is predicted by binary mechanics.
Okay.
Nobody can predict that. If someone does ride a pig,
stop talking. Right. So that's good. So give people a chance. So you've got this whole moon thing where you're showing the moon moves in the direction where it's lit, right? Well, that's an interesting observation. However, I would guess my criticism is that binary mechanics fundamentally has to do with the subatomic realm. I mean, the very basics of space itself. But the thing that you're using to prove binary mechanics is this thing that happens between the Earth and the moon and the sun having at a solar system a scale. So it's like, and it's a very complicated thing, this whole sun, moon, Earth gravity thing, which we hardly even understand. And it could be due to something else. I mean, it could be a nice coincidence that works out.
Isn't it curious? Oh, sorry. Go ahead.
It's like, it's still in the realm of the socks disappearing thing. It's like, yeah, the socks disappeared. What caused the socks disappearing? What was it, in fact, the elf stealing it, or was it the cat taking it from the hamper, or is it, we have these observations, right? So you have these observations with Grace, and you have these observations with lunar ranging. But if you look at your theory about its most fundamental predictions, it predicts the existence of the spot cube. Now, for me, if you want to prove your theory, you need to have some physical evidence that the spot cube is actually there. That would be convincing physical evidence that you took a microscope and you looked at an atom and you found something that had little following your path. That's the kind of level of detail I'm looking for, not what happens between the sun and the moon and the Earth. Things on solar system scales. I mean, that's not bad, but it's still not what I would call something which specifically and unambiguously confirms your theory, right? That's
well, the big news for all the gravity people is that all gravity effects, according to binary mechanics, are due to quantum level effects, all of them. And so there is no two different scales. That's been a ruse, a hoax, well, I wouldn't call it a hoax because that implies a bad intent, but like a misconception is, I guess, a better word. Because the just for the mainstream physics people that might be tuned in, or and I think everyone that's tuned in probably is aware of what the mainstream physics story is, that gravity effects are too weak to have any effect on the quantum level. So we have these two worlds, the quantum world and the gravity world. And they want to keep those separated because they can't explain or bridge the difference between them. As my papers, if you look at them, point out, I'm developing a multi-factor quantum level explanation for all gravitational phenomena. And it's multi-factor because there's a variety of different phenomena and a variety of different effects that may be important. As far as the comment here about we should talk about the results of GRACE and what it is. Okay, we did the lunar laser ranging thing. Now let's talk about the GRACE thing just very briefly. They put up two satellites, Y2, because it had to do with their theories about general relativity, and they could compare the gravitational force or gravimetric measurements, if you will, of the two satellites and where they were in orbit around the Earth and so forth, to find where gravity is strongest. I use the ocean data. It's divided up into ocean data and land data. And since most of the surface of the Earth is ocean compared to land, which is a little more complicated to analyze, in the ocean data, where GRACE is saying there's more gravity is where the ocean is warmest. It's that simple. And that's 50% of the variance. And so I've been so bold and perhaps undiplomatic to say, well, if 50% of their data for the ocean is merely surface temperature, as predicted by binary mechanics again, what is the other 50% of the variance? Is it just complete garbage? Is it junk? Is it, what are they measuring? They don't have a clue to what they're measuring, as a matter of fact. And the GRAIL experiment is the same thing repeated on the moon, by the way. That's GRAIL, if you want to look that up and download that data and do the same analysis. You'll probably find that where the temperature is the warmest on the moon, they're finding greater gravity in terms of their gravimetric work. So again, that's a completely different environment, and yet the theory of binary mechanics is confirmed. And now your point, Franklin, is an excellent point concerning maybe there are other explanations other than the postulates of binary mechanics for the results that I've shown, because the results do show that general relativity fails. And I think a lot of the dissidents here would be happy about that. They would say, wonderful, good show. But on the other hand, you raise a good point. Maybe there's another explanation. Well, if there are, let's see it. What we need is great minds like Franklin and others to not only just ask questions, but attempt to answer their own questions. Give us a theory that's going to explain my data and my results, which debunk general relativity, which can explain this data as an alternative competitor to binary mechanics. I'd love to have a competitor. And in science, that often speeds things along. Like you could even look in biology. I spent, as a younger man, a lot of time studying physiology. And I remember where competing labs were trying to establish the role of calcium in certain metabolic events in cells. And there were competing labs. They had this theory and that theory. And guess what? The difference in results turned out to be that one lab was washing their glassware 3 times between rinsing their glassware 2 times. And calcium sticks to the glassware. And so they had errors in their data and so forth. So that my response to what Franklin says is, I welcome what Franklin says. And I think it's astute that he says that. And yes, but it's, now's the time to step forward. Not only raise the question, but propose an answer to it. What other explanations are there? Well, propose one. I'd love to hear it. Write the paper. We'll publish it. And then, we can have people going back, well, Jim says this and Franklin's theory says that, with different explanations of the same data. How can we exclude one and include the other? That's the name of the game, man.
So you got a question here, James. So when you Google your name, we get like the names of an American stockbroker and a English footballer, but that's obviously not you. So what should people Google to find your stuff?
Probably binary mechanics, or just go straight to www.binary-mechanics.com. And I'm right there. My son is also named James Keen, but he has a different middle name, so he's not a junior. So, and he's involved in music. So that if you there's also a James Keen, exact same spelling, who is an orchestra, conductor out there in California somewhere. So James Keen is not exactly a unique name.
So Google binary mechanics. I just Googled that, and you'll get the binarymechanics.blogspot.com, and that's James's website. Right, James?
You'll find everything there is, yes. I have a domain, which is www.binary-mechanics.com, which basically feeds you to binary mechanics without the dash in there, just binary mechanics, no space, .blogspot.com, which is the where the Journal of Binary Mechanics resides. If people say, "Oh, well, that's a personal website," I was talking to someone in an email conversation, because there's a lot of email that goes on, but behind the scenes here, and I was saying, well, all websites are made by people. They're all made by persons. So they're all personal. I mean, what are you saying? I mean, it's either there's value on the website, it's of interest, or it's not. I mean, it doesn't matter. But there's a lot of misconceptions that, just by the way, this same person, who I won't name, is not basically a participant here, by the way. But that same person was saying that archive.org is refereed site. It's not refereed. Those papers are not refereed. They're just put up, just like I put up my papers. And however, in 10 years, no one has come up with, to address Franklin's point, come up with an alternative explanation of the data about from the Grace satellites, or the Lunar Laser Ranging Study, which was done in 2011, almost a decade ago, and no one has even replicated it. Although I use French observatory data, they could have downloaded data from American and Australian and other observatories to replicate the study. No one has dared to do that. I think there must be a general agreement that if they were to replicate it, they just find my same result, and then oops, all of their work on general relativity is out the window.
Okay.
And all of this nonsense.
Carl Reef is having a hard time believing in your data here. So you're saying that the moon is closest to the Earth at full moon. Is that a true statement? Which is interesting.
And also the perigee and apogee. In other words, at some time, the orbit of the moon is not exactly circular around the Earth as the center of the circle. It's a little bit oval, and so that at certain points of time, the moon, just because of that, that's called the perigee, when it's closer to Earth. And I found that the perigee can change over time when the moon is closest to Earth. And guess what? When you have the closest perigees during full moon. In other words, when the moon is emitting a lot of quanta in the direction of Earth. And of course, the motion law in binary mechanics says that objects tend to move in the direction of higher quanta density. So, and that's the whole basis of it. So that basically, as far as the lunar work, I had two dependent variables, perigee and distance measured by lunar laser ranging. They both showed the same result. During full moon, the moon's closer to Earth. The perigees are less when the moon is closer to Earth. And by the way, the programs to analyze this data are all available. Just email me. I wrote the programs. They're written in the computer language that I wrote, Hot Basic. They're very easy to read and understand the programs. So, if anyone wants to try to find any mistake in my work, I would welcome that. Anyone would like to use the same programs, but for other bodies of data to replicate the results, from, let's say, an observatory in the US or wherever, I would welcome that. All of this is available. So the gray satellites, it must be extremely embarrassing because they're all steeped in the general relativity and using those principles, and that really space-time is, warped and distorted and curved and all of this nonsense. And yet, all they show as far as the ocean data is the one single thing that's most correlated with higher gravity measurements is ocean surface temperature. And in fact, they show more gravity when the season is summer compared to when the season is winter. I mean, in say the north hemisphere, and the inverse, of course, in the southern hemisphere. So that everything is temperature related. And I mean, these people must not even be showing their face at NASA anymore, because you say, you're just a bunch of fools. I mean, it's like the cops that can't shoot straight. And yet they're getting millions and millions of dollars to put up these satellites. And then even more than that in the Grail project, to send the satellites to the moon and then have them orbit the moon and do the same doggone thing all over again. And then you won't believe all the nonsense that comes out of this, because they'll say, well, this area of the moon that has an increase in gravity, there must be some massive object under the surface. And you see, we've discovered it. What kind of baloney are people really accepting? It's amazing. Cut.
I mean, but you're still saying that the gravity is actually, there's just this relationship between heat and gravity. I think that's what was one of your papers, is that wherever there's more heat, there's more gravity. So I guess in the Sahara Desert, they should be measuring more gravity there than the forests of the tropics, I guess, or something.
Well, you can analyze the gray data and see what you get for the land data. The land data is a whole lot more complicated because, like take Europe, like it's all convoluted with, Italy sticking out here and Spain down there and the mountains here and not mountains. And, but the ocean data, which is, of course, more like 3/4 of the surface of the Earth, is what I chose to analyze. If you want to venture into the land data, be my guest, go right ahead. Let's see what you find. The data's there. That particular desert area you just mentioned, get the latitude and longitude and look it up in their database. They have it. You can just download it and look at it. And you're either right or wrong, aren't you? Or if you're saying, is my theory borne out? It's either right or wrong. Do that. Look up. It's basically a data look up is what you're talking about. Just look up the data and say, this agrees with Jim's theory or it doesn't. For the Sahara Desert or Dead Valley in the Southwest.
Once again, as you keep on running on about that same thing. So, but the main criticism here is that it's the region of applicability is like, way out there. So I would think that the other problem is that you could be cherry picking. Maybe not, but people have been known to do this, where they go around and they find evidence which matches their theory, and they point that out. But that, cherry picking. It could be contradictory evidence where I heat up something and the force decreases. With gravity, the Russians have done these experiments showing that the gravity, increases with the heat and then decreases when you get to a certain point. And there seem to be these relationships between gravity and temperature that are measured at, a relatively small scale. So, but although this whole relationship between energy and forces, that once again could be due to some other cause. I mean, generally speaking, intuitively, more energy available and could equal more force, generally speaking, right? That's what we generally think. So perhaps that's not a terribly surprising thing. But to say that, binary mechanics predicts that, it's like, lots of things predict that. If a pot of boiling water has more energy and can do more stuff than the pot of water at room temperature, it's like the binary mechanics. Yeah, binary mechanics goes along with that, but still, you don't need binary mechanics to explain that. It's just more energy, more activity. That's so. But what I'm looking for is if I were to believe binary mechanics, and I don't, you would have to show some of the intimate, the actual picture of the elf doing the stealing. That would be convincing. So for people who believe that the galaxy is a computer simulation, we are looking for direct evidence of that simulation. So for example, if you could do a physical experiment and detect a universal clock that cannot be either subdivided and runs at the same speed no matter what you do, that could be a direct evidence of, say, a digital system, something like that, something which goes down to the level of what your basic hypothesis is. The experiment that you have to design has to address the first principles of your theory, which is your spot cube, right? So my main criticism is about the whole moon and grace thing is like, well, yeah, that's interesting, but that's just due to a very bulk prediction having to do with force of gravity versus available energy, right? And that's far, 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 far away from your spot cube and what those things are doing, right? So what do you think, James? Can you come up with an experiment?
Well, what I think is that I've been working sort of as a little beaver. I don't want to take too much credit, but and there's well over 100 papers that I've put out on all different aspects, deriving all sorts of physical, so-called fundamental physical constants, as well as many, many other aspects of events in physics. And so that when somebody says, I'd like to see, what I'm saying is, well, go ahead and do what you'd like to see. It's not my job to, do the experiment that you propose or that you want to see. You devise the experiment and you do it. That's the way science progresses. It's not my responsibility to do your experiments. Okay.
Yes, it is.
Nobody has come up with an alternative explanation of the results that I presented. How can we design an experiment to put one in or out? And by the way, there's somebody showing Alistair showing something on. I showed up today not expecting to talk about binary mechanics at all. I was just going to listen, but and talk about whatever other people were talking about, not my work. So I feel a little bit awkward here. Quiet.
Wait a minute, we can almost kind of,
Alistair talk?
maybe you should
I
get
know
it
for a
closer,
fact that he can talk.
or just write it in the
Couldn't
chat.
we-
We can almost read it. It says, could we argue less, blab,
Blah.
let's, and science more?
Yeah, that's what I'm saying. I agree with Alistair. I agree, Alistair. Thank you.
I thought we were talking science.
In other words, relative, rather than just saying, well, I would like to see this, or what if that, I think that's what Alistair does not want to see. He wants to see someone step forward and say, I have designed an experiment to either exclude or include Keen's theory or Einstein's general relativity theory or whichever. Rather than just saying, oh, I think, like whatever. So thank you, Alistair. I agree with you.
Well,
More
I
science,
disagree.
blah, blah, blah.
I think we weren't doing blah blah blah. We were totally talking science. I mean, we're debating, what counts as the validity for a dissident theory, right? Me, the skeptic, versus James Keen, who has one of his dissident science theories, right? And that's very typical, right? Because the problem with a dissident scientist is that we can think of anything we want, but, well, nobody believes us. So the question is why, right? Why are they not handing James the Nobel Prize around his neck, right? Why? What's the problem there, right?
Well, the first step is to get banned. Who else has been banned among the, I guess Bill Lucas can say that he was banned. Oh, okay. So there must be something threatening to the establishment in Bill Lucas's work. There must be something threatening in my work. So far I can name two people who have been banned on YouTube and other ways. Bill Lucas has mentioned this repeatedly. I don't mention it much because, well, but why are they so afraid of binary mechanics that they have to ban it and limit its exposure?
Well, you're just lucky they don't burn people at the stake anymore.
Just lucky that what?
That they don't burn people at the stake anymore. If you had been living back in, say,
yeah, that's luck.
Back in early Massachusetts, they would have obviously labeled you a witch and taken care of you.
I'll go with that one. Yeah, I'll agree 100%.
So certainly that's part of the thing is that we're not getting the Nobel Prize because we obviously have something threatening to the mainstream. That's
to
problem.
put things in perspective. The Nobel Prize is sort of irrelevant to the derivations from first principles of binary mechanics of the so-called fundamental constants. That's something that happens like once a century. I mean, the Nobel Prize is a year-to-year thing. I mean, it's totally irrelevant. The event that my work points to is happens over I mean, it doesn't happen that often in science. It's a real rarity. It's not something where you can say, well, what's the best thing that happened last year? In the case of the derivation of the constants, it's like, what's the best thing that's happened in the last century?
Well,
and I think a lot of people would want to attack it and to show that I'm wrong, because that's when you think of it. If I just act like a journalist, let's say, that's an incredible claim. Let's show that Keen is wrong, and please do so. Come on, bring it on. I'd like to see where it's wrong. Show me. But they can't. Not yet, anyway. They can't.
We did have a little interesting discussion last week about accelerators. Now, your theory predicts that what's going on in the accelerators is that the whatever they're accelerating has to be basically dissociated into a soup. And so your argument is that since binary mechanics predicts that at high velocities everything has to disintegrate into the soup, that they're not really colliding particles, right? So that's a specific prediction. That's a specific prediction of binary mechanics. However, I would say the vast majority of scientists who work on these things would disagree with that and say, if you're predicting that, then the experiments show that you're wrong. So binary mechanics is wrong on that account.
They agree with the predictions, and that's one of the strengths of binary mechanics. All of the scattering data, like the proton scattering data, reveals the size of the spot cube that you referred to about 20, 30 minutes ago. And I didn't respond to specifically, but there's actual data from other people, the accelerator people, showing the size of the spot cube as the so-called radius of the proton, which is about 1.2 to 1.3 femtometers. And that it's not spherical, which no one has an explanation for except binary mechanics. I would like to see, for example, some other explanation, but there aren't any competing explanations. So right now we're sort of out there by ourselves, where no one can explain this data better than binary mechanics can, or no one is claiming to. With respect to the soup, I'd like to see some of the high energy particle physicists. They're called high energy because they're accelerating proton beams to nearly the speed of light. Requires a lot of energy. Estimate the actual volume of their beam. What's the volume? Calculate it. They must have some estimate of that. Then take the amount of energy in a proton. How many protons would fit into that volume? They're going to find that it's completely saturated into a soup. I've challenged them to do this calculation, yet none of them has dared to do the calculation, or if they've done it, they have not dared to publish it. Because if they did so, I think it would confirm exactly what I'm saying. And so all of those people, like last week, Bill Lucas was saying, oh, well, like I've worked, on these accelerators and so forth. And I said to him, well, great, then you have the information. Do the calculation and publish it. Let's see it. They won't do it because it'll confirm exactly what I'm saying is my prediction. I haven't done the calculation. So go. You see, like this Saturday morning chat is like a, if masters and PhD students are looking for projects for theses, I mean, it's like one study after another. They just keep rolling off the press. All of these studies need to be done. And one little guy down here on a little island in the Caribbean can't do all the studies and all of science. There's got to be some other people coming in and doing the studies also. And then
I'm no expert in particle accelerator physics, but even I know that there's what's critical to accelerators is the luminosity data, which is and they're trying to get it higher and higher and higher. It's like it doesn't turn into an indistinguishable soup. I mean, obviously they're trying to get more billions of dollars to enhance the LHC so that they can get to higher and higher luminosity levels, right? And luminosity, as far as I know, is that exactly that density calculation of how fast the protons are going, how dense they are, and they want to get it as dense as possible. But once again, I'm no expert in accelerator physics.
But you're accepting the premise, which I believe is false, that when you're getting up to the speed of light in those beams, you're basically dealing with an undifferentiated pure energy soup. Okay, and again, I would challenge any particle physicist to do the calculation and publish it. Put it on archive.org, where there's no peer review, or send it to me. I'll put it up. Let's see what you find. Do the calculations, because then when it's put up, people like Franklin and others interested in the subject can say, well, I think their estimate on the figures that they use in the calculation are a little bit off by this way or that way, and so therefore the results change, and the significance of that change is such and such. In other words, a real science discussion can take place, and that's what I would welcome.
The LHC. I'm just going to look that up and see what that gives us back here. So high luminosity, LHC, because this is definitely something we can look up. I'm going to the home CERN resources here. So let me share this here. So what is luminosity? Luminosity is a measure of the number of potential collisions per surface unit over a given period of time. It is an essential indicator of an accelerator's performance. Integrated luminosity is measured in inverse femtobarns. One inverse femtobarn equates to 100 million collisions. So that is what I'm saying that they're working on doing here. So there's no indication, since they're trying to increase the number of potential collisions, that there's no indication that the beam turns into a soup. In fact, if it did, that would make it really difficult to actually predict collisions.
It doesn't address the question. What is the volume of the beam? Like if the luminosity is such that they're saying that there's 100 million possible collisions, and they're saying that those are all protons, let's say, in the beam, then the question is, well, what is the volume of this beam?
Well, of course they know the volume of the beam. But they absolutely know.
Why don't they do the calculation that I'm saying then? They could then do the calculation and find out that they've got a soup. One thing that's not publicly
collisions. You got collisions per surface unit over a given period of time. So that's collisions per square centimeter per second. So, and that seems to be perfectly legitimate evidence that they're still looking at particles.
Not in my book. They haven't completed the calculation.
Of course, they've completed the calculation.
Per square centimeter is an area. It's not a volume. What is the volume of the beam? Now, one thing that's not public on, like if you go to, say, my website, is what papers are being viewed. And it turns out that my paper about the soup and also the video on BitChute about CERN project scientific merit ratings, where I discuss some of these things, is going way up. It's almost of some 20 or 30 videos that I produced there. Well, it's the second most viewed, almost 400 views. It just shot up. So these people at the accelerators are looking at my work, but they have no response to it yet, apparently.
Well, let's see here. The beam size is 3.5 micrometers, which is pretty small, but that is the beam size. So the volume is whatever you want, 3.5 micrometers by probably the bunch size. The bunch, each bump contains 1.15 times 10 to the 11th protons.
In what volume?
In what volume? There's a bunch. Let's call it 1 centimeter, right? And the beam size of 3.5.
Well, I'm not saying let's blow it. I'm saying, what is your calculation? Not yours, but you're looking things up, Franklin, and that's a legitimate thing to do. They haven't got to the volume of the beam yet. You just read a number of protons, so that now the next question: in what volume? We know the approximate size of a proton, its radius being about 1.25 or 1.3 femtometers. With that number of protons, according to what they're saying anyway, you could calculate the volume, couldn't you? Well, what is the volume?
But how does
You
that
notice
matter?
that they're giving you a length in one case, they're giving you an area in one case. But excuse me, when I was a little boy, they were saying that volume is like three-dimensional thing. You need a length, a height, and a width to get a volume. Or if it's, let's say, cylindrical, they give the calculation for that in elementary geometry, what the volume is.
Well, why does the
Hello?
volume matter so much?
Well, I'm saying that if you pack enough energy into a particular volume, you no longer have differentiated particles. There are not protons in there. It's just pure energy.
Well,
And
obviously,
then you could
Elliot,
ask the question, why is my paper stating this so popular? It was written like, why is this such a popular paper?
I have
It's
no
popular
idea.
because
but,
it asks some very fundamental questions about what they're doing and how they're characterizing what they're doing. Like I have no objection to the fact that all of these jets and a massive amount of particles and then decaying into subparticles occur when these very high energy so-called proton beam collisions occur. All I'm saying is it's not exactly proton collisions. You're colliding two beams in opposite directions of basically pure quanta energy, with almost completely undifferentiated. And unfortunately, the CERN people, none of the research groups, and they got 20 million a year funding. Okay, you can go to the nsf.org and go to the physics section and look at the multi-million-dollar, the highest money projects, and you see what kind of money they're getting, and not one of them, and they claim to have thousands of physicists involved. Not even one of those physicists has come up with any kind of a response or a rebuttal to what I'm saying. Not one. You know why?
That it's obviously
My guess is that they can't rebut what I'm saying. That's why. Because if they could, I think they would. But that's a speculation.
Well, I mean, once again, I'm not a part of
about my work, okay? Because that
but if I were, I would say that, that's what Bill Lucas is saying. So Bill Lucas is an actual particle physicist, not me. But as what Bill Lucas said is that you're wrong, James, because they are definitely particles. Even at those speeds, they're definitely protons. So if binary
mechanics, I asked them to
that they're not,
confirm that, and it's been silent.
It's not silent. Bill said himself that it's not a matter of.
I heard what he said last week. Yes, and I asked him to confirm that, and so far I have received nothing. Not on my email, not on this show, not anywhere. He hasn't confirmed that. He hasn't definitely. So he can say what he wants to say.
I mean, I showed you in the LHC.
That doesn't get us anywhere.
Clearly, in the LHC, they're saying they are expecting collisions of particles at those energies. They can express it in, collisions.
And that's why my paper is so challenging. It challenges the very basis of their whole conception of what they're doing. And isn't it interesting that there's no rebuttal? They have not been able to come up with any rebuttal. And my guess is why not? Probably because they're not able to.
No, the rebuttal came from Bill Lucas, which is that, no, you're wrong. They are particles. They're definitely particles. That is the rebuttal.
Well, yeah, you could say anything you want to say, but show me the numbers, show me the volume, show me how you're going to calculate the number of protons in that volume, and then we can talk turkey. Then we can talk, well, your estimate of the volume might be a little bit off by 10%, or your estimate of the number of protons might be a little bit off, blah, 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 and we could get down to specifics rather than just saying it. Because anybody, as you
yeah,
have pointed out, Frank,
LHC
anybody can say anything.
I think I did do that. I mean, went to the LHC website. The beam is 3.5 micrometers long. There's like 10 to the 15th protons in each bunch, you know, and when they collide it, they get a specific calculated luminosity, which is based on the
so far we don't have volume.
volumes of protons and things like that.
And we don't have volume. Okay. So what you're saying is that from what you looked up on the net, they don't publish an answer to the question.
Yeah, they published, you know, they're looking for number of collisions per.
Then we could talk about it. But there's nothing to talk about because they refuse to even address the question.
No, the question has been addressed. Is that no, the particles do not turn into a soup at those energies. They just don't. Everything I read in that website, that's what it indicates. The particles do not turn into a soup. That is a wrong prediction of binary mechanics.
Well, you haven't shown the data.
Yes, I have. I mean, the data from these
LHC matter of number of particles per volume. And you've given me a length of a beam. You've given me an area in one instance that you looked up, but no volume. Isn't that curious how they avoid the central question? Why? Because they're getting 20 million a year by saying that it's proton-proton collisions. And they're going to come out and say, we've been taking all of this money, 20 million a year, for how many years? And really, it's not proton-proton collisions? I don't think so.
Let's see. Let's get off of this topic here. So, now we've got Harry. And I'm not exactly sure who this question is directed to, which is how do you explain the difference between electric photons and magnetic photons in your theory? Well, gee, I didn't even know there were magnetic photons, so I'm not sure. Well, I don't understand this question, Harry. It's like because no one talks about electric photons either, let alone magnetic photons. So, if you want an answer to that question, you might have to clarify what that means. But let's see here. This one's more towards you, James. So, if attraction is defined as density of photons, where the motion is towards the higher density of photons, how do you explain the electric attraction between positive and negative charge? That's one for you, James.
Well, I really don't talk about the density of photons much, but how do you explain the electric attraction between a positive and a negative charge? Well, the electrostatic component of the time development laws of binary mechanics is called the scalar bit operation, separates like charges and like sign charges, I should say, excuse me. And apparently the net effect of this is that negative charges tend to get closer to positive charges as a result of this dispersion effect. In an experiment where I followed the center of mass of all of the quanta in the proton bit cycle with a positive net charge and the electron bit cycle, which has a negative electric charge over some 20,000 simulator ticks, it appeared that the center of mass of the electron was following the proton in their movement around the space, the random movement around in the simulated space. So those are two comments that I might make. One's an observation, and the other one refers back to the basic time development laws. And so the net effect is that it looks like the lower mass negative charge net quanta in the electron bit cycle appear to follow the proton bit cycle quanta.
Okay, you're repeating yourself. So Harry's got another question here. So how do you? Yeah. So when you're done explaining your question, try to explain things in as succinctly as possible, because Harry's got a lot of questions. So how do you explain the attraction between currents in the same direction and repulsion between currents in opposite directions? So basic electromagnetic 101 question here.
I don't have any comment on that. I'll defer to others.
Okay, so you don't necessarily explain this, which I would agree with. I mean, it's,
off the top of my head, no. Now, no. At this instant, no.
Your theory has to do more with the subatomic realm and not so much with orchestrated kind of reactions, because we're talking about wires. We're made out of matter, and you have charges running through those matter-containing wires, creating fields, and it's all very complicated.
Well, that's an artificial distinction, because everything at the macroscopic scale is a direct consequence of what's happening at the quantum scale in my work. So that's an artificial distinction.
Now let's see here. Harry's got a comment. I'm not quite sure if this is. Mainstream science proposes that they have certain knowledge, and so you must agree that what they say is true. I don't know if that's true. If someone questions a theory, that means what is said in textbooks may not be true. And I would, as a dissident, I would say, no, I don't have to agree with what mainstream science says. In fact, that's what my whole shtick is about. And if they question a theory, it means that what's in textbooks may not be true. And so it's like, absolutely, that's what this show is all about, because we don't believe, we don't agree with the knowledge, and we don't agree that what they say is true. And when we're questioning it, that means that the textbooks are false. Yeah, so that's what we're doing here. So that is a direct disputation what textbooks say is true. So they have a truth review system to prevent discussing alternate theories.
Yeah, it's called banning and shadow banning.
Banning, and then we also have the journal review process, which ensures that nobody who has any independent thought will be allowed to be published. Except now we have the internet, so anyone can publish anything they want anytime. It's like, I think I'll a bunch of crybabies now, because it's like, who cares? You're getting the journals, just show it out there in the internet. You can put it on Vixera, whatever, and anyone who's interested in the subject can search it and find it, right? So it's not like the journals are the gatekeepers of knowledge anymore, right? They'll never publish James's stuff, but James's stuff is getting out there to the point where they can ban it, right? Okay, let's see here. Once again, so if photons are the cause of interaction between photons, what is the difference between the electric action photon and the magnetic action photons? Once again, kind of hard to say that. Now, I could possibly try and answer this. And let's see. So your final statement here is, long statements are not possible in chat, so I have to break up what is said into separate posts. Oh yes, that's correct. That's perfectly fine. But so Harry, let me try and take a stab at this question. I think this might be directed more towards me, anyways, because I have theories about magnets and light photons and things like that. So first of all, if photons are the cause of interaction between photons, what is the difference between the electric action photons and the magnetic action photons? Well, I wouldn't necessarily characterize them as, I don't know, photons, but let's just talk about the electric field and the magnetic field and what's going on there, okay? So we have photons, that's like typically light waves. Okay, let's just agree light is a photon. So we have that kind of physical interaction. And then we have magnetic fields, the things that come around that surround magnets and cause electrons to deflect, right? Same thing we see in old CRT screens, okay? So I think a CRT screen might kind of like demonstrate the difference of the effects. So if we have, I mean, if you have an electron beam, there's two ways you can deflect an electron beam. One is that you can deflect it with a static electric charge. So you put you have plates, one plate is positively charged, one plate is negatively charged. If you send an electron beam between the two, then the charge will deflect upward. So that's one. So that's what the action of a electron through a electric charge. The other way you can deflect a beam is through a magnet. If you take a electron beam and you put a magnet next to it, that will also cause the beam to deflect. But we think that these are two different actions. So Harry's question is that now that we've kind of defined what the difference is and the difference, how it acts on, say, charges moving, well, what is the difference between that? Is that your question, Harry, about, what's the difference between the magnetic and the electrical deflection? So Mainstream says that EM force is mediated by photons, but there are two kinds of EM force, electric and magnetic. So how does one type of mediating photon produce two different types of force? Okay. Yeah, we have what appear to be two different things, magnetic field and electric field, but they do the same thing, which is they both deflect electrons. So let's talk about the electric case, I guess, right? So first of all, I don't think that the electric field, strictly speaking, is, well, it is kind of. I mean, you have to go to, what is coming out of a charge, right? So what I think is coming out of a charge can be represented like a wave, right? There's something at a specific frequency coming out of, say, that you have two plates and there is some thing coming out of the negative charge and the positive plate. There's something coming out of that which is creating a field, and that could be considered the photons, right? Photon is also a wave, right? I'm thinking the electric charge, also effectively a wave, right? So that is what the electric charge and photons are doing. And when the electron goes through the plates, what they're doing is that they're actually seeing an asymmetric force, and the electron is being shoved downward by essentially the waves hitting the electron. Now that's not a full explanation, but it's like a ship going through a sea of waves and getting pushed around. So that is really crude, but that kind of gets you the idea of what I think the action of the electrostatic force is. It's just waves hitting some object and it's being pushed along the way. And now the magnetic field is a different animal entirely. So magnetic fields are being caused in the presence of moving charged particles, right? So you have to have a moving charged particle that's going along. Now these charged particles are emitting their electric field wave, like I explained. But that doesn't have anything to do with it. You have moving charges. And what I think that does is that it basically causes the space around the moving charges to be aligned. It's like if you've ever been in a flag pavilion and you see the wind that goes through the flag pavilion, all the flags start pointing in one direction, right? According to the wind, right? Now, if you were to go and start throwing balls into these flags, depending on which way they're pointing, they're going to be deflected in different directions. So this is, once again, another crude explanation for the action of the magnetic forces. But if you throw a ball, right at the flag, it's just going to bounce off. But if it's pointing this way, it might actually go all the way through. But if you're doing this way, it might get deflected off in some other direction, right? So, and Harry's saying he's asking James and not Franklin, but I think James answered that it's outside the region of his applicability, right? Right, James, this is kind of outside the whole region of your applicability. Is that not? Let's see, you're muted, James, or we can't.
Okay, unmute. I'm now unmuted. Thank you, Franklin. No, I mean, as I said about, a while ago, all of these effects that you're talking about on a macroscopic scale arise from the basic quantum events, whether we're talking about gravity or the effects of the wind on the direction that the balls are going to hit the flags or whatever. It's all from the quantum effects. So macroscopic physics laws and observations, such as all rise from the quantum level of analysis.
Yeah, we know that they all, but Harry is asking the perfectly sensible question of what's the difference between the electric field and the magnetic field? I mean, it doesn't matter that they arise from the same place. It's like, that's
well, in binary mechanics, I would, first, as a preface, I would urge Harry to come online live, and so that we can have these questions right back and forth, rather than brief written comments, because I think that would be very instructive and useful. In binary mechanics, the difference is that there are two different bit operations which define the time development of any physical system. And one is the scalar, which has to do with electrostatic effects. And one is the magnetic vector bit operation, which has to do, and that goes down to the fact that there are two kinds of quanta, what I'm calling the M quanta and the L quanta. And, so, yeah, that's intrinsic to binary mechanics, that there are these two. And those are two of the three fundamental forces, the third being the strong force.
Okay, Harry. James does have an answer between, I mean, it sounds like it's a fundamental different force thingy in your theory. Although, like I said, I would answer differently. I would say the difference is that the electric field is using waves to directly push the particle. The magnetic field just sets up like a set of flags around the space that's around the wire. And when you throw electric charges into that space, they get knocked off course, basically, because of that orientation, right? So the magnetic field, strictly speaking, is not being caused by the photons. The magnetic field is an alignment, some kind of alignment or polarization of the space, which causes particles, charges that are going through it to be deflected. So, like I said, that's kind of my dissident, unsupported, against the mainstream explanation of how that works. But since you bring up photons, I've had a major discovery this week, which is I think I have discovered the actual shape, the physical shape of a photon. Now, this is not a crazy if you look up the question, what is the shape of the photon? Some people will try and answer this. Physically, what is the shape? And I think that the answer is as important as, say, the discovery of the DNA helix, right? Because before they discovered the DNA helix, they had no idea how biological molecules encode information in a sensible manner. They just kind of knew what the pieces were and what it was made out of, but had no idea of what the and what it did, but had no idea what the actual structure was. But what I am saying is that I have come up with the actual physical structure. I mean, you could draw a picture of it, physical picture of the photon. So, and this is what it is, okay? So you heard it here first, the shape of a photon. Okay, so the shape of the photon has to do a couple things. Most importantly, it does have to encode the polarization angle, right? We have a wave, and now typically that polarization angle has been encoded in, say, the transverse wave component. You've seen the standard EM wave description, and they have the the sinusoidal thing, and the polarization is encoded on the angle of the, say, the electric or magnetic wave. It really doesn't matter because they're at 90 degrees each other. So, but there has to be something that encodes that. But now the shape of the photon is not a sinusoidal wave, right? Because physically you can draw that on the chalkboard, but that's not an actual realizable shape. What I think the shape of the photon is, first you have to understand it's a wave phenomenon, right? It's like what you see in a wave tank, right? So, but to envision the actual shape of a photon, you have to envision, let's say, a wave tank which is very long and skinny, right? Now, maybe you've seen these. They have these at the aquarium where they have this long and skinny tank, and they start a wave at one end, and it goes all the way across to the other end until it hits the shore, right? Okay. So, but what you see there, the wave, it's got like a very specific, concentrated area where it's the maximum. That wave travels along that little corridor. That is actually the shape of photons, right? Now that's like a two-dimensional, but in 3 dimensions, it's a region of concentrated medium, right? And effectively, it's like a rod. So I'm saying that the photon, if you were to give it a physical shape, would be the shape of a rod, right? So the rod, if it's coming towards you, it's going to be like, if you can imagine that this is actually a wave front, and this pen actually just represents a region of concentrated, compressed, call it ether, whatever it is, some medium, right? So this is like coming at you like that, right? Now the polarization is encoded on the angle. So if I send you a signal this way, it's going to be different than if I send it to you this way, right? But as it travels through space, it can be effectively considered a rod. Now, as a rod, I would think it must have some actual physical extent, right? That could be measurable in, meters, right? Now, I don't know what exactly that is, but it can't be 0 or it can't be 1. It's got to be, if you're like me and James that think that space is quantized, then it's going to be some quantized length. Let's just say it's like 5 or something, or maybe it's 10. But perhaps one of the consequences of quantized space, I'm thinking, is that if this hypothesis, this is a hypothesis. It could be as crazy as the elves stealing the socks in the dryer hypothesis, but one of the things that might predict is that since space is quantized, that the angle of polarization, this thing, if it's going through quantized space, can't be, and if it has a fixed length, it can't be continuous. That at some point, maybe you might measure that the angle of polarization has to be quantized. Maybe that could be confirmation That's just one prediction. That could be false, but it might be true that if that's the shape. So that's why we do science. That if you have a specific hypothesis, I propose the shape of the photon is actually this thing, and as opposed to being a combination of, say, magnetic and electric fields. That was we were discussing last week with displacement current. That's another possible. But if it's that, then it would seem almost absurd to discuss the shape of an electron, because it's just a field, disembodied field that's waving some unknown amount in the middle of space. I mean, if electric waves actually travel that way, then I would think that the photon has no shape. It's a bunch of fields. It's no shape at all. But I would say my hypothesis is that it's the shape of a rod. And when you're thinking about, how light is generated, it generates these rod-like structures, and that's why the energy in them is quantized. And because I think that when light strikes an atom, it hits the atom. This is the electron, hits the atom, causes the proton or the nucleus to vibrate back and forth. And when it vibrates, it sends out these rod-like wave phenomenon out into the world. And the frequency is just, the how closely these rods are spaced to each other. And I think that when light is generated from atoms, it has to do at least two, right? Otherwise, it wouldn't have a frequency. So otherwise, then it would just be a soliton. So there, that is my new proposal on what I think a light wave is. And it's like this whole week we've been discussing this whole question about, the E and the M and the B of, light waves. But I'm saying it's all a bunch of baloney because it's actually just a compression wave that's shaped like a rod. So there you go. That was my little shtick there. So if anyone has any comments on that, I'd like to hear about that. That's just something I just came up with this week.
In support of that, I haven't delved into in my papers much about exactly what a photon is, but except to say that it's a collection of quanta in some kind of a packet, or going in the same direction, or something of this nature. So that the idea of a photon is apparently a collection of quanta, which would agree with the general idea that Franklin was saying. A second point I'd like to throw in, if I may, is that if we're talking about, well, there could be this or that other theory which would explain my results, like with respect to gravity and lunar laser ranging and the GRACE satellite data and so forth. And the question is that these other theories or ideas have to be expressed mathematically. All of my work has precise mathematical definitions. There's no hemming and hawing about that. They're very specific and written down, and anyone can read them, like what the basic bit operations are and so forth. So that if someone says, well, there's another explanation, this has to be reduced to some expression in a mathematical form, because one may find that it's simply an equivalent representation of the same thing or not. But one can't even begin to do that analysis until an alternative explanation for my results is expressed mathematically. Cut.
So Harry is saying that all actions at the quantum level, so that implies all interactions are via photons, which is the quantum of EM action. I mean, I think, maybe your photons are, the bit operator. I don't know that photon is the correct terminology here, but
Well,
I'll let you
without getting too technical, you're talking about EM action, and that brings up Planck's action constant H. It turns out that constant depends upon the value of alpha, which depends upon quanta density, according to my work. The more fundamental is what I call the elemental action, which is Planck's constant multiplied times alpha. Since alpha is 0.07, you're getting a value of about 137th of the value of. So in other words, Planck's constant seems to deal more with the photon level of analysis, where you have a whole lot of quanta involved in a particular interaction, and it depends upon alpha. Whereas my elemental action does not depend upon alpha. It depends only on the primary constants for mass, length, and time, which are the fundamental full quantization postulates of binary mechanics. So they qualify as first principles.
So Harry keeps on asking the question again about how attraction is produced between different charges. Although I think you explained this, that you put a proton and an electron in your simulator and they spontaneously came together. Would that be the correct understanding?
Yes, and both the positive and negative charges tend to repel each other by the electrostatic time development operation, which I call the scalar bit operation. So that if you're scattering plus charge and you're scattering minus charge, you can imagine, well, where are they going to go? The pluses and the minuses would tend to get closer to each other. And that might explain the observed level on the macroscopic scale that negative sign charges attract. And so it's all consistent with what we see on the macroscopic scale.
Except you said a couple contradictory things like negative charges attract, and negative charges by themselves will repel each other, right? You didn't mean to say that, right?
Well, I meant to say, if I misspoke, excuse me. I meant to say that the electrostatic scalar bit operation for time development of any system would tend to separate like signed charges. In other words, they would separate, cause negative charges to repel each other or move away from each other. And to us, we use the word that they're repelling each other because that's what it looks like, and that's fine. That's an apt description. So that if both the positive charges are repelling each other and the negative are repelling each other, where are they going to go? Apparently, there's a tendency when that happens for the positive charges to get closer in the net, in the aggregate, to the negative charges, and we call that attraction at the macroscopic level. But the point I'm making is that all of these events at the quantum level account totally and completely for all macroscopic observations that we know of. That there's not a barrier between the macroscopic level and the quantum level, in other words. They've tried to erect this barrier to hide their ignorance.
There's this other question, potentially self-relate from the derivation of Planck's radiation law. There's a lot of math involved. I'm not sure if that's a question or a comment. Me personally, that's too much math for me to comment on that. I don't know if you have a comment on that, James.
Well, I derived it from the electron spin. Okay. And there's an accepted relationship between the electron spin and Planck's constant. So if there's something wrong with that, please let me know. I'd love to know.
So we have some other comments about the magnetic field. So magnetic field lines aren't really real. They are abstractions. Also, they're representation of parts of a medium that have rotated in place due to torque. Magnetic fields represent electrical torque. Well, I mean, definitely there's something there that I can agree with in that that they represent, it's a representations of something that's going on in the medium that have rotated, right? I think I would agree to that. I mean, if you took a magnet and you put compasses around it, you can see that clearly the compasses rotate in place. And what I'm saying is that the magnetic field is actually those rotated compasses, right? That it's an orchestrated event as opposed to a direct event, because I think, Harry is still asking, what's the difference between the electric and magnetic and electromagnetic? How does a single type of photon explain the three different actions? So I'm saying that the electric is a direct pull action, like gravity, right? That is the how the electric field. The magnetic field acts as basically a kind of interference that is set up in the surrounding space. It's an orientation, like the previous commenter said, it's an orientation of something in space itself. Like I said, it's like the flags are being blown by the wind and you're throwing balls at them. They deflect the moving particles in a different way. So it's actually more of a collisional kind of thing, but also ultimately, I still think it's an electrostatic force. So you have the electric field, negative charges attract positive charges. What I'm saying is that the magnetic field sets up these dipoles, which have positive and negative charges. And when you throw electron balls through those dipoles, it becomes subject to the electrical field between those dipoles, and the negative charges is attracted to the positive end of these dipoles. So fundamentally, even the magnetic force is an electric force, which is mediated by a photon, which is nothing but a wave, right? So once again, my opinion, my crazy dissident theory, no confirmation, but I mean, it's an interesting question. How does the magnetic and the electric force mediated by exactly the same thing, which we think is like a photon, or in my case, I think it's a wave, right? So the fundamental force is the electrical force. All forces derive out of the electrical Coulomb force. The magnetic force arises out of a geometric alignment of particles in space. This is why I think the magnetic field has limited distance, because there actually has to be something physically actually aligned. Material particles have to be aligned in space around the wire that's carrying current, and that cannot exist for infinite distances. It's like you fill the entire world with compasses and you put a magnet in your room, and the compasses will align with the magnet out to a certain distance. But after a while, there are other forces that cause the magnets to align to different things. They might align to the Earth's magnetic field, or even if you're in a room that didn't have any magnetic fields in it, just heat and random activity would cause those compasses to point in different directions at some far distance from the magnet. As opposed to an electric charge, you put an electric charge in the field, that acts as a wave that will go for an infinite distance, right? That can just go forever, right? And like I said, the way you think about photons is that you think of them as like a rod-like structure. Now, I do have to say that I do believe that radio waves are a different kind of phenomenon. Radio waves are not little rods. Now, the difference between a radio wave is not basically quantized. a light that comes off of atoms is quantized due to the fact that they're coming off a quantized thing, which is a nucleus, right? But a radio wave is generated by a long, skinny thing like a radio antenna. And so when a signal comes off the long radio antenna, it comes off in basically the shape of the antenna. Like if I take an antenna and I dip it in a wave pool, if it's a skinny long rod, the wave will come off as a skinny long wave off of the rod that way. As opposed to if I got a circular antenna and I dip that in the wave pool, you'll see that the waves take on the shape of the antenna, right? And so this is the way I see radio waves propagating. Radio waves propagate as compression waves. Once again, I don't think it has anything to do with electric fields or magnetic fields. I have been challenging people all week for them to show me any experiment that shows, say, the magnetic field transiting, empty space. And well, at least Harry, he found at least this was very interesting. He found a trimeter which can separately measure the radio spectrum, the magnetic field in milligauss. See, that's good because milligauss is the measurement of electric field, and can measure electric fields, which should properly come out as volts per meter, right? So maybe I should spend $146 to get this thing because I want to go take this up to like a big radio transmitter, like a big TV transmitter, transmitting at 10,000 watts and see how much electric field and magnetic field there is, right? And this thing is sensitive to AC signals, right? So that's what would be coming out of any radio transmitter, AC signals. It wouldn't be just one constant magnetic pull in one direction. And it is sensitive in the ranges that these transmitters operate at. So yeah, so spend $146. Go take it up to the big transmitter and see what actually happens. I don't know what's going to happen. I mean, maybe it would show that yeah, there's a lot of magnetic and electric field around that transmitter. In which case, my theory is blown up, right? Okay. Or I guess my theory would predict that you'd see humongous RF, but negligible magnetic and negligible electric fields when you get like maybe 500 feet away from the transmitter. Maybe if you're right up to the transmitter because it used so much electricity, maybe you'd see something. But I guess my theory would say that you wouldn't see very much. You'd see massive radio frequency, but very little actual AC magnet and electric charge. But I'm thinking it just doesn't travel out. The radio field travels as a gigantic compression wave. And once again, the polarization of that is carried on the shape of the wave front. So instead of being a rod, you can consider it like some of the other suggestions here on the comments is that maybe it's like a big arc, right? Big arc. So as it comes out of the radio transmitters, this is a gigantic arc coming out. And but specifically, if we set up a polarization experiment where we have a vertical antenna and maybe a horizontal receiver, that when the horizontal transmitter transmits, it transmits this big vertical wave, and when it gets received by the big vertical transmitter, it's like all the energy hits at the same time, just like that. Like my whole arm hits at the same time. But if I have a horizontal thing, when the vertical wave comes in, it only hits at just the very crossing of my hand, so very little of the energy actually gets transferred. But if they're aligned, then the entire bit gets transferred. And in case of polarization, when the wave hits and gets absorbed like that, it actually gets totally absorbed. It's converted into electricity and then turns into heat. So the wave actually disappears. So generally speaking, we don't see things like that with, say, sound waves. That's why sound waves are so hard to polarize, because we'd have to have something that when it receives the wave, it completely absorbs it and then takes it away. But generally speaking, when sound hits any flat object, it reflects. It's not really absorbed. It still has the capability of pushing, but it doesn't really absorb the same way that I would say radio waves get absorbed. So let's see here. We're getting towards the end of the hour here. And let's see, we've still got some other comments that I want to get to. So Harry is saying that a photon is a particle, not a wave. You are saying a particle is a wave. That doesn't work. Well, I'm not sure who this is exactly addressed to, because I would most certainly say that a particle is not a wave. You know, if Cornelius is here, he would definitely say a particle is a wave. Totally. I mean, certainly people believe that. And but what did I say? Is a photon a particle? No, I would not say that a photon. I would say photon is strictly a wave. It's not actually a particle. And then we have this whole particle versus wave duality. Although an interesting thing I was watching, I sent around a video on EM waves in the email, and what they stated was that at low frequencies, everything acts like a wave, total wave. At the opposite string, like gamma rays, everything acts like a particle. And in between, like in light, they have attributes of both. So that, I'm not sure if that's true. I think it's strictly a wave phenomenon, and it only becomes particle because they're transmitted by these, particle-like rod shapes, which I announced today. That's my big, Nobel Prize winning announcement. Just like the DNA structure, that's what a light photon looks like, right? But not to be confused with radios, which don't come out as photons. I don't think radio waves are quantized. And an experiment I'd like to see is that, try to do the photoelectric effect using radio waves. I think that you would not be able to do that. That would be my prediction, that would not work. Let's see here. We answered that. Let's see here. So we have the comment, I think photons are systems of impulse force times time and torque, which it could be. Moving averages are used in stock markets and for impulse analysis. I think they are relevant to photons too. Possibly. So there is no electric field or magnetic field as you define them. We are talking about static fields which do not exist in a radio wave. So is that some kind of agreement that there's no electric field? I mean, there is this difference between the static field, like coming out of an individual charge, or what's coming out of a magnet. Those are static fields. And certainly the radio wave would not be static. We're talking about an AC signal. That's why I'm interested in that meter you pointed at. It's like, yeah, that thing can measure AC signals, right? Can even measure the direction that the AC signal is coming out of, right? Which are all good things. But I think a magnetic field is a magnetic field, whether it's static or not. So I don't know about that. And finally, particles are bits of energy according to 20th century physics. Yeah, that has to do with that whole E equals mc squared thing. That particles like electrons are somehow a bit of energy, right? I completely disagree, but that is certainly one thing that mainstream believes in. But so it looks like we're getting to the end here. Okay, so let me summarize a little bit about what we were talking about. So today, we had James on. It's been basically the James and Franklin show today. And it is what it is. So sometimes only some people are blabby, and that would be James today. But I invite other people to come and join the conversation in the live room. Apparently, we can have up to 10 people now. It used to be like 6, but now we can have 10. and invite you to come and join the live chat. But we were mostly discussing James, and James was making the claim that, no one has been able to disprove his theory. And I would say, yeah, that's true, because you cannot disprove theories that people come up with in their mind. So we explored that a little bit to see exactly, what justification does he have? And we explained a little bit about the grace experiments, the gravity experiments, how there seems to be some relationship between gravity and energy, and that's predicted by binary mechanics. But my point was that, okay, well, that could have been done with that may have been due to something else. So that we still need some physical evidence. We still need to see the picture of the elf going in and stealing the socks. That's what we specifically need to see there. So, and I think that, you started to get into some of the actual evidence, which might be, if the accelerated experiments show something about, the size specifically, then, if your theory predicts a specific size for your spot things, and we see things of that exact specific size coming out of these things all the time, then, that would kind of count as more direct evidence of seeing the actual sock stealing going on versus something which is kind of on the galactic scale. That's just kind of my. So
we do see things of those size.
Yeah,
it's been reported for decades.
So I don't know if I've put any, any worrisome thoughts in your mind about, why is it that people don't believe our crazy theories? And of course, one of them is that they would burn us at the stake because they don't like crazy theories. So we discussed a little bit about why none of us why the Nobel Prize Committee has not knocked on my door and said, Franklin, we want to give you 7 Nobel Prizes for figuring out how gravity and how the electrostatic charge field and how magnetic field and how all those things work. And I tried to explain some of those today because Harry was asking the question of what's the difference between the electric field and the magnetic field, right? So you've heard it from James. For James, it's kind of a fundamental property. We have these 2 tiny forces. For me, it's an actual physical difference in how the fields work, but ultimately everything is, as Harry says, all forces caused by photon interaction. And I announced, what is the shape of the photon? So they should give me the Nobel Prize for that, but I'm guessing not. Or maybe I'm wrong. But it solves the ultimate problem, which is how do you encode transverse information in a compressive medium, right? That's the whole trick, right? Because as a physicalist, I want to do everything as can be demonstrated on a billiard table, right? Generally speaking, it's hard to demonstrate electrical fields on a billiard table because the only thing that happens is things collide into each other. That's it. You can't have mysterious magnetic or electric fields or actions at a different distance. All you can have is things crashing into each other. So ultimately, it has to get down to that level, and that's what I was trying to do with my explanation of the shape of a photon. See, there's the photon coming right at you. So. But that will do it for this week. If anyone else comes up with any, mind-blowing Nobel Prize winning thoughts during the week, then please come and chime in. And you heard it here first. So thanks everyone. See you next week.